File and folder permissions in Linux are actually really simple. There are just 3 tiers of access: the owner, group, and everyone else. And for each of those tiers of access, they can either read, write, or execute. That's it. It doesn't get any more complicated than that. And as always, let's get a terminal open, and we're going to go to full screen just so that it's a little bit easier this time in this lab. Okay, so let's get started with a side-by-side comparison of 2 folders. We'll first look at the root folder, and we'll go to the root directory to do that. So let's cd down there to cd/to root, and then let's go and look at the file and folder permissions for the /root directory itself. So as you can see here, we can see what the permissions for folders are, but we can't look inside of them if we don't have permission to do that, and that requires read access. So running ls-tacl on the /root directory gives us a permission denied error, and that's because if you look at the permissions here, you'll see that there's no read ability for us. And how do we know that? Well, if we look at the line permissions over there where it says drwx and then a bunch of tac lines, those hyphens over there, we would expect to see some additional characters towards the end. So let's actually zoom in a little bit here and just go tier by tier and break down what this structure actually looks like. The first set of characters we see, that D is actually representative of a directory. The read, write, execute, or RWX right afterwards is set for the owner permissions. Next we have the group permissions, and in this case there's nothing set. They're all just set to these tac lines. If they had permissions, we would actually see it being set over here. And then finally, this last section is the everyone group. So this would be how us as Ubuntu is trying to access this folder. And as you can see, again, nothing is set, so therefore we don't have any permission to access it. So how do we know who's the owner and what group this belongs to? These next 2 columns tell us that. So the first one is the owner, and the second one is the group. And don't pressure yourself to make sure that you understand all that in one go. That's sort of impossible. So just keep working with it. And let's look at this next example here of our home folder of Ubuntu. For example, we can see that the owner over here has full read, write, and execute permissions, and we know that it's a directory because of the D in the front. And if we want to know who the owner is and which group it belongs to, we can look at these next 2 columns right ahead. All right, and probably still a little bit confusing, but I think it'll make more sense if we just continue along and start messing around with the permissions themselves and let it land a little bit harder that way. So let's go into our home folder now. And what we're going to do is we're going to actually create a new folder, and we're going to call it Precious. So we're going to create our Precious, and we're going to use that touch command just like we've used to change file stamps, which creates an empty file for us as a result. And something that we haven't covered before is to determine what type of file type something is once it's made or just on disk. So if we actually run the command of file, this is a command that allows us to determine what the file types are of a given file. If we run file on Precious, we can see that it's an empty file. And that's how that touch command is working. It's creating an empty file for us. And this is a useful command to keep handy if we ever want to figure out what type of file something is. All right, so let's move back to file permissions. We need to use the chmod or chmod. You're going to hear it being called by that often as well too. This command changes file mode bits, which is probably confusing. So let's look at the man page and see what we can find out, and then let's break that down a little bit more. If we scroll a little bit into the man page, we're going to see that there's a statement here that says a numeric mode is from 1 to 4 octal digits, so 0 to 7, and it's derived by adding up the bits with values of 4, 2, and 1. Still probably confusing. The omitted digits are assumed to be leading zeros. So there are essentially 4 digits that need to be changed to change file permissions. And once those digits change, they represent read, write, and execute, or a combination of them. The first digit is pretty advanced. We don't want to really look at that right now. What we're actually going to be trying to do is just change the file permissions for the user who owns the file. So that's the second digit. And then we want to be able to change the third digit for the group permissions, and then we want to change the 4th digit for the permissions of everyone else, and that includes our Ubuntu user account. And again, that's actually probably going to sound really confusing, and it always is at first with Linux permissions. So let's actually just try and walk through this together. And I've thrown a little chart here in the bottom that kind of breaks down how these numbers might work. Let's say that we wanted to give permissions for the owner to have full read, write, and execution. We would want to add up the numbers of 4, 2, and 1, and then set that permission value. And remember what I said, that we're not going to look at the first digit yet. So the second digit technically is the owner, and we can actually omit the first one. And 4 plus 2 plus 1, last I checked, pretty sure is 7. So we'll set a permission value of 7. And then we don't care about the rest, so we'll set the third and fourth digit as zeros. So let's see what that actually looks like. If we run a chmod of 700 and then enter the file name afterwards, and then run an ls-tacl on the file just to see what the permissions are, we'll see it set. So owner has rwx permissions and everyone else is set to 0. Now, again, that might be a little complicated at first, so I think what we'll do is let's walk through the everyone group and start from the beginning all the way to the top. So from 1 all the way up to 7. And let's just keep doing this and then checking the file permissions. And you can see how now the X bit has been set. And this is what it means by changing file mode bits. And they're representative of a value, this octal digit value that can go from 1, 2, and 4. So 702 means that we've now provided write access for the everyone group. And if we go now to 3, which is actually write and execute, so 2 plus 1, we now see write and execute set for the precious file as well too. And so on and so on. So the value of 4 means read. And now we can look at that again and we can see that it's set for just read access. Now it's getting a little tedious running the ls command right afterwards. So what I'm going to do is add 2 ampersands at the end. And this is a new operator you haven't seen before. This is called the logical AND operator, that if the first command ran is successful, then run the second command right after. So let's start running the ls-tacl command right afterwards and get our output. And that's a lot easier this way because we're trying to demonstrate a concept over here. So let's keep moving up that chmod ladder and keep increasing the value. And as we can see, by increasing it to 5, we've now provided read and execute access. And if we go up to 6, we now have read and write. And then finally, if we go up to 7, we now have the full permission set possible of read, write, and execute. So it's really just a number of digits over here that represent the combinations of how you can change permissions. And the way that these digits are set, in this case, you're seeing me using 3 of them because I've dropped the first one. That first digit over here is for the owner, the second is for the group, and the last one is for everyone. All right, so now that we've been through that, let's actually set our precious back so that only we can have access to it. We want to drop that last permission and put it back to 0, and now only we as Ubuntu can access our precious. No one else, it's only ours. And finally, just for some good measure, let's put some text inside there because in the next lab, we're going to validate that no one else can actually touch our file. So let's go ahead and run an echo and put in some text, whatever you'd like. I'm going to go with the theme here and just say that they'll try to take it from us. And I'll put that inside of the file over here. And in the next lab, we're going to, again, validate that no one else can actually touch it. And really, that's it for file permissions. So the concept is pretty simple, right? We have owner, group, and everyone. The only complicated part is just trying to think about how numbers can represent read, write, and execute. But once you get that down with a little bit of practice, that is the extent of the real complexity for setting file and folder permissions in Linux. It's really simple afterwards. So let's see you in the next one and make sure that no one can actually get inside our file.